Hi everyone. So in this video, we're going to work through another Year 12 stats question from the AS 2018 paper. And this question is on binomial distribution and hypothesis testing. So NASA is playing a game with two friends. The game is designed to be a game of chance so that the probability of NASA winning each game is 1/3. So NASA and his friends play the game 15 times. So for part A, find the probability that NASA wins exactly 2 games for part I. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams are finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app and you'll be able to access all of these 2027 predictions. Okay, so we've got seemingly here a fixed probability of winning each game, and we have 15 games, so a fixed number of trials. Which distribution do you think this is going to be? This is going to be a binomial distribution. So for part A, part I, if we call X, or if we define X to be a binomial distribution with 15 trials and a success rate of 1/3, then in this question, we're finding the probability that X is equal to 2. Okay, so we get 2 wins out of 15. So what we're going to do is we're going to use the calculator and we're going to use binomial PD. So remember, when we have an equal sign in the probability, we're going to use binomial PD. So we'll go to that section of the calculator, just going to mine right now. And we want the X value to be 2. We have 15 trials and we have a success rate of 1/3. So this is giving me a probability of 0.0599. And then we can leave it like that to 3 sig figs. Or if you want to give 4 sig figs, that's fine as well. This would be a 5 there to 4 sig figs. So that would be part I. Now for part II, find the probability that NASA wins more than 5 games. Okay, so with this one, we're looking for the probability that X is greater than 5. So more than 5 is greater than 5. Now another way of writing this probability would be to say that this is the probability that NASA wins at least 6. Because obviously you can't win a decimal number of games. This is a discrete distribution. So this is the probability of winning at least 6. And you can also write this as 1 minus the probability of winning less than or equal to 5. So you can also write that as well if you want to. And if your calculator does not allow you to put in different inequality signs, because for example, my calculator does not allow me to put in different signs, but I know some calculators do allow you to change the inequality symbols around when you use binomial CD. So remember, when you're accumulating probabilities, like in this situation, you're going to use CD. So on my calculator, I'm going to have to plug in the probability that X is less than or equal to 5 to start with. So binomial CD. So my X will be 5, again, 15 trials, 1/3 success rate. So we've got here 1 minus and then 0.61837, so on and so on. So 1 minus this number on my calculator gives me 0.3816. Again, we'll give that to 4 sig figs, but a 3 is fine as well, 0.381624 sig figs. Perfect. So that is part A completed. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now let's go to part B. So now then, NASA claims he has a method to help him win more than 1/3 of the games. To test this claim, the three of them played the game 32 times and NASA won 16 of these games. Stating your hypotheses clearly, test NASA's claim at the 5% significance level. So of course, this is a hypothesis test. So let's just do this on the next slide here. So remember, we always start with our two hypotheses, H0 and H1. So if we go back to the question, what would H0 be, the null hypothesis? Well, the original hypothesis was that the probability NASA wins a game is 1/3. So that is going to be our H0. P is equal to 1/3. So the alternative hypothesis, let's just read the question again. So NASA claims he has a method to help him win more than 1/3 of the games. This is what we're testing. So the alternative hypothesis is the probability is bigger than 1/3. So this is a one-tailed test, okay? If it was two-tailed, you'd have the not equal to symbol. Now then, the next step is to define our probability distribution. So what I'm going to do, because I've already used x, the variable x in the previous part, I'm going to use a new letter. So what we can do is we can let y be number of games that NASA wins. And this would be, again, another binomial distribution. How many games was it for this part? It was 32 this time. Okay, so now the number of trials is 32, and the success rate is 1/3, assuming H0. So remember, with our hypothesis tests, we have to assume H0 is true to do the calculation. Now then, the next step would be to look at the result we got. So when we played the game 32 times, NASA won 16 times. Now, what you could do with these questions, you could just work out the expected value. You don't have to do this, but the expected value, the expected number of games would be 32 times 1/3. So you would expect NASA to win the game about 10.6 recurring times. So 10 and 2/3 of the time. So 10 and 2/3. So we've obviously ended up with more than that number. We've ended up with 16. So if we do like a little number line here, I like to do this with these hypothesis tests, just to visualize the problem. So what I'm going to do, I'm going to put the expected number in the middle of this probability number line. Again, you don't have to do this. I just like to explain this, or I like to use this with my students to explain the concepts here. Probability line, call that. So the expected again is 10 and 2/3, so essentially 32 over 3. We've ended up with 16, and we have a 5% significance level. So our 5% significance level is there. This is our critical region there, and we need to determine if 16 is in the critical region. So what we need to do is we need to find the probability that x is greater than or equal to 16 and compare that with 5%. So again, this is the same as 1 minus the probability that x is less than or equal to 15. So again, we're going to use our binomial CD. So binomial CD to do this. So I'm going to go to my calculator. On my one, again, I have to work out the probability x is less than or equal to 15 first. Again, we had 32 trials with this one. And I'm going to put 15 in there. So this is 1 minus 0.962347 to 6 decimal places. So I'll give 6 decimal places here. So 962,347. So 1 minus that number there will give me 0.0377 to 3 sig figs, we'll say. So about 3.7%, 3.8%. Now that is less than 5%. So that tells us that the number 16, let's use a different color here. The number 16 is somewhere in this critical region up there, because the probability on this part of the number line is about 3.7%, which is lower than the 5%, or I say 3.8% there to 2 sig figs, about that value. So what does that mean? Well, 16 is really far away from what we expected, so we have to reject H0. So we're going to reject H0. Sufficient evidence, there is sufficient evidence to suggest that NASA's method helps him win more than 1/3 of the games. Okay, so remember, with your hypothesis test conclusions, you want to relate your conclusion back to the context of the question. Okay, so the question is about, does NASA's method help him win more games? Well, the evidence suggests so, based on the probabilities there. I mean, we can't prove it, of course, because we're collecting data, but there is sufficient evidence to suggest that, yes, this method seems to improve his success rate. If you do have any questions, do drop a comment below, but hopefully you are all fine with everything we've done in this video.